Hi guys, welcome to another session of News in 30 minutes. I hope you're doing good and I hope your preparation is on track. Today, let us look at some of the important issues on 13th of January 2024. Before that, another appreciation to all users because most of the students on the pretext or context of a long weekend would have gone to their hometown, would have stopped studying, would have been deviated, but you people are tuning in and you people are serious enough. So on that behalf, I would like to appreciate all you people for the dedication and sacrifice that you people are putting in for pursuing your ambition and dream. So with that, let us get on with some of the important issues on 13th of January 2024. Now, before we start off again, Monday being Sankranti, it is going to be an holiday. So I'll not be able to do a video on that day. So I'm wishing all of you people a very happy Sankranti festival in advance. With that, let us start off with the first issue of the day. The first issue is air in Delhi, Patna most polluted, Navi Mumbai worsening, 5-year NCAP analysis. Since the National Clean Air Program, India's flagship air quality management initiative was launched in 2019, cities like Varanasi, Agra and Jodhpur have seen significant reductions in PM 2.5 and PM 10 levels, while other cities face escalating pollution levels. Okay, so this article is mainly talking about a program called NCAP. This question was actually asked even in the MINS exam. So the air pollution as a theme is very important both from prelims and mains perspective. Okay, so for example, they will keep asking you what are all the different pollutants of vehicular emissions, what are the different pollutants in different types of industries. So in that way, indirectly, air pollution is a theme that is very important for your prelims as well as mains. Okay. However, since NCAP has completed 5 years, it is necessary for us to understand the entire factual dimensions from prelims perspective that will help us eliminate options and to reduce answers. So let us look at the factual dimensions of what is this National Clean Air Program. Okay, so one by one, let us start doing it. So as I told you, National Clean Air Program has completed 5 years. So it was launched in 2019 and this program was basically to target or to reduce two types of pollution, that is PM 2.5 and PM 10. PM 2.5 and PM 10 means particulate matter. The full form is particulate matter, or it is also known as fine matter, and 2.5 and 10 are nothing but 2.5 micrometer in diameter, or it is 10 micrometer in diameter. So these are very fine particles, especially this 2.5 is very fine particle that can get into our lungs and cause several irritants and asthma as well. Okay, and this over prolonged exposure will also cause cardiovascular diseases. Okay, so the main job of National Clean Air Program is to reduce PM 2.5 and PM 10. Initially, the target was to reduce the PM 2.5 and PM 10 to 20 to 30% by 2024. However, now the target is revised and the revised target is to reduce PM 2.5 and PM 10 by 40% by 2026. So this is the new target, and the reduction, the base year for this reduction is 2017. 2017 is the base year. So taking this as the base year, we have to reduce the pollutant of PM 2.5 and PM 10 to almost 40% by 2026. That is what is the target. The next is which are all the cities that the National Clean Air Program focuses on. The Clean Air Program focuses on 131 cities. These 131 cities are segregated into, one is non-attainment cities. One is non-attainment cities, and the second is million plus cities. Non-attainment cities and million plus cities. So what are these non-attainment cities? Non-attainment cities are those cities that have exceeded the national ambient air quality standards set by CPCB for consecutive 5 years. Okay, so again I'll repeat, the non-attainment cities are those cities that have exceeded the national ambient air quality standards set by CPCB for consecutive 5 years. This is what is the non-attainment cities. So together 131 cities have been targeted to reduce the PM 2.5 and PM 10 by 40% by 2026. Okay, so this has been targeted from around 24 states across India. Okay, along with this, NCAP also warrants the preparation of city specific action plans. It also warrants city specific action plans. Okay, so this is something from prelims perspective that you have to know about NCAP. The just a few dimensions from mains perspective also is the performance of NCAP. Okay, one out of the targeted 1500 manual monitoring stations, out of the targeted 1500 manual monitoring stations, 818 has been launched. 818 has been launched. Okay, the next is 131 cities. All the cities that are targeted have developed their own city action plan. They have developed their city action plans. The third is there is a PRAN web portal. There is a Prana web portal that is created, and this Prana web portal basically assesses the performance of cities, and it also allows monitoring of the air pollution standards. Okay, so performance and monitoring. So these are the three aspects. Now the challenges that are with respect to this particular national clean air program is the performance of the states, the performance of the cities have been not satisfactory. The performance of the cities has been not satisfactory. The pollution levels of several cities have not gone down. In fact, it has remained the same, or it has in fact gone up. So that is a problem. The second is CPCB will monitor only PM 10 properly. It does not have enough equipment to monitor PM 2.5 in all cities. That is another problem, because PM 2.5 requires special equipments. CPCB does not have such equipments to monitor them. The third is the funding. Funding is also a problem in order to set up such stations. The fourth problem is regarding compartmentalization of rural and urban areas. Now CPCB is basically, NCAP, that is the National Clean Air Program, is basically focusing on the 131 non-attainment and million plus cities. But what we should know is air pollution is not something that is confined to a boundary within the city. The air pollution can go to different areas, it can disperse, and it can also attack or it can pollute rural areas. So this compartmentalization is also creating a problem. And the last challenge is no carrying capacity. No carrying capacity studies has been taken place in any of the 131 cities. Okay. Now when we say carrying capacity studies with respect to air pollution also, there can be carrying capacity studies. So in the context of air pollution, how do we define carrying capacity? Okay, so carrying capacity is the region's ability. Carrying capacity is the region's ability to accumulate, and disperse. Ability to accumulate and disperse emissions while maintaining breathable air quality. Okay, so basically what they tell us, see, for example, if a city has less skyscrapers, let us assume that if a city has less skyscrapers, okay, less skyscrapers, then obviously the air movement will be very smooth. When the air movement is very smooth, that means the whatever emissions are there, that gets dispersed easily. When emissions gets dispersed easily, the air will be more of breathable quality. So with more dispersion and more breathable quality, we can say that this city has high carrying capacity. Okay, and those cities, let us say if there are cities that have huge or high density, that has high density skyscrapers, they have high density skyscrapers. In this scenario, since the wind movement is confined, the air is not easily dispersed, and when air is not easily dispersed, that particular region will have high pollution and less breathable quality. And because it has less breathable quality, the carrying capacity in the context of air pollution will reduce. So this is a concept of carrying capacity regarding air pollution, and no carrying capacity studies has been done in any of the 131 cities. So I hope you understood this concept of carrying capacity in the context of air pollution. However, the overall picture is about the National Clean Air Program. Okay, so this is about the issue. It was launched in 2019. It's been 5 years since the launch. It basically was aiming to reduce the PM 2.5 and PM10 pollution by 40% by 2026. And PM 2.5 and 10 indicate the size of the particulate matter, that is 2.5 and 10 micrometer respectively. And they are basically targeting cities, especially 131 non-attainment and million plus cities. Non-attainment being those cities that have exceeded the national ambient air quality standards set up by CPCB for the consecutive 5 years. They are called as non-attainment cities. So in these cities, you have to reduce the PM 2.5 and PM 10 by 40% compared to their base year of 2017. So this is the entire setup of what is National Clean Air Program. So I hope this was helpful from the prelims and mains perspective. So let us go on to the second issue of the day. The second issue is, why is the Square Kilometre Array project significance of India joining it? Okay, so what is the Square Kilometre Array project and what is the significance of India joining it? The Square Kilometre Array means something that is arranged, a small unit that is arranged in order. When smaller units are arranged in a particular order, then you call it as an array. Okay, so basically Square Kilometre Array is nothing but we are trying to build the world's largest radio telescope. So I told you, in the electromagnetic spectrum you have in the electromagnetic spectrum you have VIB-GOIR. Okay, VIB-GOIR is the visible light. This VIB-GOIR is also known as optics. So red, if you take red, any energy less than red is known as infrared. Any energy less than infrared is known as radio waves. Okay, so infrared, radio waves. And if you take violet, any energy greater than violet is UV rays. Any greater than UV rays is X-rays. Any greater than X-ray is gamma rays. Okay, the reason I am writing this electromagnetic spectrum is, see, electromagnetic spectrum is nothing but electromagnetic radiation. This electromagnetic radiation is found in space. Example, sun's insolation. Sun's insolation is nothing but electromagnetic radiation. That electromagnetic radiation will have these different energy bands, or that radiation has different frequencies of waves. Okay, and the frequencies of waves are gamma rays, X-rays, UV rays. Then you have the visible spectrum, which is called as VIB-GOIR. Then you have infrared, and then the IR. Infrared, that is IR, and then the radio waves. So overall, this is the electromagnetic spectrum. So if I have to study the space, I have to have spectroscopy. That is, I have to have tools to study in different spectrums. And there may be some telescopes that will study in visible and light spectrum. There will be some telescopes that will study in IR spectrum. There will be some that will study in UV or X-ray. So depending upon the sensors, the spectroscopy changes. However, the reason why I am telling you this is the next two topics is to do with telescopes. The next two topic is to deal with telescopes, and in the telescope, one telescope is dealing with radio waves. The other telescope will deal with visible, that is optical wavelength, as well as IR. Okay, so in these two topics, when I am telling radio waves as well as visible and IR, you should not by heart it English via English. You should try to visualize this spectrum. Okay, which energy bandwidth will those spectroscopy be done in order to assess the space? On that lines, I am trying to give you this radiation electromagnetic spectrum table. Okay, so coming back to the square kilometer array. So the square kilometer array is an attempt to build the world's largest radio telescope. So basically, when I say radio telescope, this means that we are interested in radio astronomy. Okay, we are interested in radio astronomy. Radio astronomy is trying to study space through radio wave spectrum. Okay, trying to study the wave through radio wave spectrum. Now look at this. This is the radio wave spectrum. Okay, so trying to study through radio wave spectrum is what is the radio telescope. Okay, the next topic is nothing but 30-meter telescope. That is the next topic that you will be learning. In the 30-meter telescope, it is nothing but a telescope that is trying to assess or study the radio waves. 30-meter telescope is to study the space at the spectrum of visible light, that is optics, at the spectrum of visible light as well as infrared. So the 30-meter is basically trying to study the space in this energy bandwidth. Okay, whereas the square kilometer array will study in this bandwidth. Okay, so I hope you understood the concept of this. Okay, don't try to buy out the next time, understand. Okay, so first topic, let me just take up, as I told you, the first topic is square kilometer array. Okay, so array, I told you array is nothing but smaller units that are arranged in order to form a huge system. But one, as I told you, this is something that we are attempting, we as in the world, the community is attempting to build the world's largest radio telescope. When we say radio telescope, I hope you understood, in order to have radio astronomy, that is to study the space with radio waves energy bandwidth. Okay, now why is this in news is because India is about to become a full member. India was partially a member to this square kilometer array, but now India is set to get the status to become a full member. Okay, now how to become a full member? One, we have to sign and ratify an agreement. The second is we have to contribute financially. So the second condition is we have to provide financial contribution. So since India has done both the aspect, India is now getting the full membership of this square kilometer array. The next point is, as I told you, we are trying to build the world's largest radio telescope. But what you should not, you should not misunderstand is, it is not a single large telescope. It is not a single large telescope. It is nothing but a collection of thousands of dish antennas. Okay, so the more the dish antennas, the more radio waves that we can study in space, and the more deeper we can go into space to study this. Okay, that is why the number. Okay, the more the telescopes, the more the smaller units that we can collect and put, the greater we can penetrate through space to study the space via radio waves. Okay, so the next is, it is not a single large telescope, it's a collection of thousands of dish antennas that are operating. These thousands of dish antennas operate as a single unit. They operate as a single unit. Okay, now the third is the antennas. Okay, the antennas currently are placed in, there are 200 antennas that are placed in South Africa, and around 1,30,000 antennas that are placed in Australia. So currently this is the status. Okay, they are spaced in sparsely populated area. They are purposely spaced in sparsely populated area to reduce any type of interference, so that we can observe the space more clearly. Fourth, you should know is, though India will become a full member of Square Kilometre Array, no SKA facilities will be located in India. That is, there will be no dish antennas that will be put from India's side. Okay, so there will be no type of facilities that will be located in India. Okay, so what you should realize is, there are several projects where India has become a full member. But India does not have any type of location, or India does not have any type of location, any type of project that is located in India. Okay, there is no location in India. One example that I will give is, India is a member of International Thermonuclear Experimental Reactor, which is famously called tokamak. Okay, India is a member of this International Thermonuclear Experimental Reactor. This is trying to create a concept called nuclear fusion. So India is a member of this. India is participating in this, but again, there is no part of the project that is located in India. India is learning a lot from it, but there is no project located in India. The second is, India is also a member of Large Hadron Collider. As you know, Large Hadron Collider is a particle accelerator. Okay, it is basically a particle accelerator that is trying to study the behavior of subatomic particles. However, if you see, India does not have any type of this project located in India. It is still done in the foreign soil. It is just that India is a funding member, as well as the scientific community participates in it. So in the same manner, the third project is the Square Kilometre Array. If India becomes the member, again, no project of this is located in India. It is just that India will be a member in foreign soil. Okay. Now then, what is the advantage of being part of SKA is, because you get priority access to the use of telescope. So basically what happens, if there is a telescope, there are different countries that will apply for using of this telescope, and these countries have to wait until they get their time and date where they can use. But if you are a full-term member, then you will get priority access for using this particular radio telescope more faster. So that is one of the advantage of being a full-time member. And radio telescopes are very, very important in studying space, and India has always been in the helm of studying radio astronomy. To just give you an example of how India is very advanced in terms of radio astronomy, India already has something called a giant meter wave radio telescope. Okay, it has giant meter wave radio telescope, which is known as GMRT. This GMRT is a telescope that is very advanced, and this telescope itself is used by many countries around the world. India actually gives this open access to this GMRT on the basis of allocation of time. This is located in Pune, but several such telescopes are located in different parts of India, but this is the main telescope. So like this, radio astronomy, India has already been at the helm of radio astronomy. So being part of this Square Kilometre Array will again push India to much more research at a deeper level in space. So hence it becomes very significant for India to be a member of this Square Kilometre Array. So I hope you understood the concept. The concept is, you understood the significance and you got to know what is this Square Kilometre Array. It is nothing but a radio astronomy or radio telescope that is nothing but collection of thousands of different dishes, antennas, in order to study the space via the energy bandwidth of radio waves. Okay, so if you look at this electromagnetic spectrum, we are done with the Square Kilometre Array. Now let us move into the next type of telescope, that is 30-meter telescope. So there it is nothing but the telescope that will read, or that tries to learn space via the energy bandwidth of optics as well as the bandwidth of IR. So let us go to the next topic. The next topic is Indian delegation visits Hawaii to discuss the progress of 30-meter telescope. Okay, it is Indian delegation visits Hawaii to discuss the progress of 30-meter telescope. Okay, now before I just come to exactly what this 30-meter telescope is, let me give you the context of why they have gone to the Hawaii. Okay, the reason why they have gone to Hawaii is the 30-meter telescope TMT was scheduled to be constructed in a place called Mauna Kea. Okay, this Mauna Kea is an inactive volcano. Mauna Kea is an inactive volcano that is located in Hawaii. Okay, and the judiciary of Hawaii had stopped the progress of TMT because of the local protests, and because the locals had protested, it had stopped the TMT. After that, there has been several progress that has been done, and to discuss on this progress, the Indian delegation has gone to Hawaii. Okay, this is the context. Now let us come to what is this TMT. As I have already told that this is going to be the world's advanced telescope. This is going to be the world's advanced telescope. This is ground based telescope. Okay, ground based telescope that is going to assess the space in optical, near infrared, and mid infrared observatory. Okay, so it's the world's advanced telescope, which is the ground based optical, near infrared, mid infrared observatory. So now I hope you understand what is this optical, near and mid infrared observatory. Okay, the next is India is a founder member. India is a founder member of this 30-meter telescope. This project was approved in India in 2014 itself, and this project is done as a joint collaboration. It is done as a joint collaboration by the following countries. Okay, which are the countries? One, obviously it's India, then you have USA, then you have Canada, then you have China, and then you have Japan. Okay, these are the joint collaboration countries which are moving to do this 30-meter telescope. Okay, again I will signify it as TMT. If you take the 30-meter telescope, basically again this 30-meter telescope is made up of segmented mirror design. It is made up of segmented mirror design. Okay, so basically what is segmented mirror design? We are arranging 492 individual mirror segments. We are arranging 492 individual mirror segments. Now all segments will work as one, and it will create a diameter of 30 meters. It will create a diameter of 30 meters as a single reflective surface. A diameter of 30 meters as a single reflective surface. Okay, so this is what is the 30-meter telescope. So India's contribution is, in this 492 mirrors that will be put, India's contribution will be 83 mirrors. 83 mirrors will be manufactured, and it will be put up by India. That is India's contribution towards it. Okay, and India's TMT India, that is called 30-meter telescope India. This is the project. Okay, this project is jointly funded by, one Department of Science and Technology and Department of Atomic Energy. These are the two institutions that jointly fund the TMT India. Okay, so TMT India is a joint study by 3 institutes in India. 3 institutes have taken up the responsibility to handle the TMT, that is 30-meter telescope India, and these 3 institutes are, okay, so TMT India, the 3 institutes that are responsible for the study and manufacture and other works regarding the 30 meter telescope is one is ARIES, that is Aryabhatta Research Institute, Aryabhatta Research Institute for Observational Sciences. Okay, so this is Aries. The second is IIA. Now this Aries is located in Nainital. Again, factual dimensions are important, so learn this. Aries is located in Nainital. The next is IIA, that is Indian Institute of Astrophysics. Okay, Indian Institute of Astrophysics is located in Bangalore. Okay, the third institute that is responsible is IUCAA, that is Inter-University Center for Astronomy and Astrophysics. So this is located in Pune. Okay, so these are the three institutes that are responsible for TMT India, and as I told you, it is jointly funded by Department of Science and Technology and Atomic Energy. 30 meter telescope is a ground based observatory that studies space from visible and IR, and hence it will help us understand deep space at this particular energy or bandwidth. India's contribution is 83 out of 492 individual mirror segments, which are all assembled to act as a single reflective surface of the diameter of 30 meter. So this project is yet to take off because of some local issues. Hence the Indian delegation has visited Hawaii, where in Mauna Kea this telescope is set to be situated. So this is about the 30 meter telescope. So I hope you understood how to go about the prelims preparation, especially in science and tech. In science and technology, always focus on two aspects. Okay, the first aspect is obviously your conceptual clarity. You should not try to by-heart English there. You should have conceptual clarity. For example, if it's a telescope that is working on radio waves, what is this radio telescope? What is this optical telescope? What is this infrared telescope? You should have conceptual clarity. Just by by-hearting that English will not help you deduce answers. The second is the factual dimension, obviously. The factual dimension being what are all the institutes that are responsible, which is the institute, which is the department that is funding it, who are all the collaborators. So like this, 492 segments, like this, these factual dimensions are what is important. So if you have the knowledge on these two at every topic level in science and tech, that means that you will ace it in your exam. Don't forget, science and tech is very important for your prelims. 15 questions come directly from science and tech, out of which easily you can score 10 to 12 questions with conceptual clarity and factual dimensions. So I hope you are prepared. Always make sure that whatever is happening in the realm of emerging technologies, the questions will always pop up from that. So you should be well versed with whatever topics are happening from the realm of current affairs. Okay, so with that, I will end today's issue. If you have enjoyed this video, please make sure that you like, share and subscribe. Okay, and please invite more friends to watch the video, because more the number of views, more incentivized we are to do this on a regular basis. Again, a very happy Sankranti to all of you. Please be safe, take care of your health and be consistent in your studies. Spend family time, work on your mental health, but please make sure that you have that momentum. Don't give any gap on that momentum. With that, I will meet you on Tuesday, and I will come up with the important issues of Monday and Tuesday on the Tuesday's video. So I'll see you again. Bye guys.